Morning everyone. Today I'm going to discuss about some programs, and I think in the last class we are going to discuss about lucky number. I think you all have practiced that number. I think now I'm going to discuss about the same while loop, about how to find a digit. I'm going to find a digit here. For example, the number is like this, and I'm going to give one more input, that is going to be some digit, single digit. This input is going to be from 0 to 9 only. Okay, for example, I'm giving some 2, the output is going to be like this. It is true. That means yes, 2 is found in this number. For example, and another input, for example, 1 2 3 4, the digit is 8, the output is false. Okay, now I am going to write this logic. Just listen carefully, everyone. Example, I am going to, first of all, I am going to search this 2 digit, right? For example, I am going to search with the last digit and the next digit and the next digit. For example, if the number is found, if the digit is found, I am coming out of the loop. There is no need to check all the remaining numbers, right? All the remaining digits. There is no need to check. Then I am coming out of the loop. For example, here 8, I am going to check with 4, 3, 2, 1. If it is not found and a whole number is going to be checked, then it is called the number is not found here. Okay, right? We are going to print a false statement here. Then I'm going to apply here int number. I'm going to read first of all, and I'm going to read it %d comma ampersand num. Then I'm going to read one more thing, that is called digit, right? I am going to read one more thing, that is called digit. I'm going to read the next one as a %d comma ampersand digit. There are 2 inputs, that's why I'm reading 2 inputs, number and the digit. Okay. The next one, we are going to write a loop here. Write a loop on the number. And I'm going to write some r for the digit. For example, r is equal to num mod 10 and num is equal to num by 10. This is the base program for all our programs. Okay, then we are going to check that if digit is equal to r, I am going to check like this, right? If digit is equal to r, if digit is equal to r, some flag is equal to 1 here, and I am going to take that flag is equal to 0 every time. What is 0 means? If a flag is 0, if a flag is 0, it refers to, it indicates false. It indicates a false every time. It indicates false. That means that is not in the list, not in the number. Okay, that means I am going to check every time f is equal to 0. I am going to take here f is equal to 0 here. F is equal to 0 here. Yeah, 0 is refers to the digit is not in the list. I am taking like that. Okay, I am modifying here. I am modifying here. If digit is equal to r, if the digit is equal to r, I am going to modify it as f is equal to 1. F is equal to 1, and I am going to print it as true here. True here. I am going to print it as true here. Now, after the loop, I am going to write if f is equal to 0. For example, if f is equal to 0, I am going to print it as a, that's it. And I am going to put a break here. There is no need to check that another numbers, right? If the digit is found, I am not checking that here. That's why I am going to coming out of the loop using break statement. For example, if I am going to execute it, I'm going to execute it. For example, 1, 2, 3, 4, and the digit is 2. Yes, it is going to be represented with true here. For example, I am going to execute it again. 1, 2, 3, 4, and 8 is the digit, and it is going to be referenced as a false here. Just look at here. Just look at the logic, how easy I am writing here. Okay, is it easy or not? Very easy. Okay, why I am writing break? There is no need to check the remaining digits. If the digit is found, there is no need to check the remaining digits. Okay, just note it down, everyone. Just note the code. Note the code, everyone. How I am writing, just write the comment also. Can I trace it? Can I trace it with manually? Anyone? Is it understand or not? If it is not understand, I will explain it with the number again. Students, anyone? Okay, everyone note this question, note this answer, solution here. And I'm going to write here. For example, the inputs are like this. For example, the inputs are like this. The question sometimes in competition every time it is going to be like this. For example, 2 here, and 2 test cases are there. 2 test cases are there, and the output is like this. And the output is like this. This is the, for example, this is the input, and this is the output here. What is this 2 means? 2 is reference to the test cases. How many test cases? And these are the test cases. In every test case there are 2 digits and 2 outputs, and the output is the true and false. Why? Because for 2 test cases the output is, the first case for true, the second case is for 3. For example, this is going to be 3 or anything else. And what we have to do for the test cases? Okay, and before this one, for test cases we have to take 2 more digits, that is capital T and small t here. First of all, we have to read the test case. We have to read the test case. How many test cases are there? How many test cases are there? I am going to read here. Very important, just look at. We have to read how many test cases for the variable t, and I am going to write for t is equal to 1, t less than equal to capital T, and t plus plus. And I am going to write inside all this one in this loop. All this in the loop. That's it, nothing else. All this is the test cases. Test case loop ends. Test case loop ends here. Okay, this is the test case here. Just look at here. This is for test cases. This is for the test case. For example, if I am executing this one, I am giving now 2 is for test cases. Now I am going to write here as 4 and the digit is 2 and the output is like this, and look at here, it is not printing anything else. Why? Because every time we have to, for every test case, we have to make that f is equal to 0 again. For every test case, right? For every test case we are going to change the f value to 0. That's why it is not printing. Now I'm going to write the logic here. For example, two test cases. 1, 2, 3, 4 is the input, and the digit is some 2. It is going to be print like this, and the number is 1, 2, 3, 4, and the digit is 8. It is going to be false here. There is a small, very small differences when we are writing, when we are dealing with the test cases here. What is it? These are the adjustment variables are there. Some adjustment variables, all the adjacent variables, we have to modify it again. For again, we are going to modify it. Why? Because for single test case, f is 0. For every test case, I am going to write it as f is equal to 0 again. For every test case, here there is no need to write f is equal to 0. Yeah, here I am declaring that I am using this as 0 here. For every test case, I am going to write here f is equal to 0. But look at here, the input is like this, the output is like this. But what is coming here? For our case, the output is coming like this. Yes, the output is coming like this. But yes, there is no problem for that. That is also true. Don't bother about, some students are thinking that this is a false one, this is not coming exactly in the competition. For example, the test case are like this. I am going to copy this, I am going to give all these things, and there is no problem for that. If the numbers, if the input and output are like this, okay, both are same, no problem for that. Okay, the online compilers are asking like this every time, how many test cases are there, then we have to work like this. Don't combine all the inputs and all the outputs and just to have to print all the test cases result in the outside of the result. Don't write like that. This is enough. Okay, some students are thinking that we have to combine all the outputs and we have to print all the outputs after the test case. Don't do that. That is not necessary here. Okay, just write as normally, no problem for that. Just maintain a loop for the test cases. That's it. All the adjacent variables, adjustment variables, we have to declare it again. We have to redefine it again. Not declaring, we have to redefine it. For every variable, the flag value must be 0. You have to write like this. Okay, note it down. This is the test cases scenario. For the test cases scenario, we have to write like this. Write this comment also, everyone. I am coming from this. Just note it down. The same program using test cases. Capital T is for test cases and T is for some loop. I'm writing some T is for loop. Why I'm not taking the I here? For example, some I we are going to take in the loops, right? That's why every time I use for test cases a T and a capital T. Okay, capital T is for test cases and T is for iterations. Okay, write this one. Okay. Now I'm going to teach about some concept like functions. I'm going to teach every time at this moment only the functions concept. For example, I'm going to develop the same program using functions. Okay, develop the same concept using functions. First of all, I'm going to discuss about something about functions here and functions. And there are nearly four types of functions, four different types of functions are there, four types. But here I am going to discuss about up to only two parts only, two types of functions only. I am going to discuss now. Why? Because when we are moving after the arrays and strings, I am going to discuss all these things. And now I am going to discuss about two types of functions. That is every time with arguments. Okay, with arguments without return type, without a return type, with arguments and without return type, with argument with single value as written, single value as written. Okay, I'm going to discuss only these two types, here. These are the basic types, basic and very necessary types here. With arguments, without return type and without return type, and single value. Every time the function is going to be written only single value. What is function? First of all, function is a particular task, that's it, nothing else. It's a sub block, that's it. It is a particular task, we are going to do that one. Okay, some part. For example, we are going to shop and we are going to buy something. That is some function, that is our part, right? We are going to some college and we have to study. That is a part, of in our life. That is some function. We are eating, that is some function. Everything, some block of functions. Our life is in a block of functions. The same thing here also, we have to develop a functions. For example, printf statement is there. Printf, this is a function. Scanf is a function. Okay, all these are predefined functions. All these are predefined functions. Already it is defined, just we are going to give some data here. I am going to give some data here. It is going to give, it is going to be, it is what it is working, it is going to be display the data in the curly brackets. What is in the curly brackets? It is going to be displayed on the console screen. That's it. Scanf, it is going for reading. In that way, we are going to give, for example, sum of a comma b here. There is no function for sum of a comma b. We are going to develop that sum of a comma b function. These are called user defined functions. User means myself or you. You are going to define that function. You are going to develop that function to do a particular task. That is called function. For the function, what I am writing here with arguments without return type. with arguments, without return type, with arguments, single value as a return. Single value as return. Okay? That means if you are doing some function, if you are doing some work, if you are doing some work, for that work you get something. Okay? For sometimes you didn't get anything. You are doing some work, but you didn't get return from that work. That is called with arguments without return. Okay? But this is with arguments with one value, we are going to get one value. If you are doing something, for example, I am going to give sum of 10 comma 15. I am going to write here 10 comma 15. The result is going to be 25. I am going to get one value that is called, for example, 25. It is going to be produced. Okay. First of all, I am going to write the sum of two numbers program using function. Just look at everyone. First of all, hash include. Okay. I am going to read two numbers. For example, a is equal to some a comma b. That's it, nothing else. And the sum on the result. There are three variables: a comma b comma result. Here I am going to read a comma b, percentage d and percentage d, comma ampersand a comma ampersand b. I am going to read two values here. Okay. Now I am going to. There are two parts in function. Two parts in function. How many parts? Two parts. Two parts in function. Two parts in function. The first part is called. The first part is. What is the first part? The first part is function call. The second part is function definition. First one is function call and the second one is function definition. What is function call? For example, one student is there. For his name is Satish. For example, I am calling Satish. Yes, sir, like. For example, there is no Satish. For example, I am calling here Satish for 100 times. For example, in our class there is no Satish is there. He cannot respond to my call, right? If it is if the definition is not there, for example, I am calling that function, there is no use here, right? The definition is there, I am not calling Satish, then that is also no use. The definition never works, right? If I call, then the definition is there, then only it will be respond to my call. Okay, like that we have to develop these two things. Function call. Then, for example, I am going to write here like this. This is the function call. That means I am going to call sum of like this. I am shouting here sum of, but I am going to shout it with the two arguments. How many arguments are there? Two arguments are there, and we have to observe here. We have to observe when we are. This is a function call. We have to observe this one. What is the name of the function? The name of the function is sum. And how many arguments I am passing? Two arguments I am passing, a comma b. And what are the data types? The data types are both are integers. We have to observe all these three parts every time. When we are seeing that function calls, we have to observe what is the function name. The function name is sum. How many arguments I am passing? I am passing with two arguments. What are the data types for each argument? For every argument, it is going to be int and int. Okay, and the last one we have to observe, if the function is like this, if the function call is like this, the return type of the function is void. Void means nothing. Okay, then how I know that if the function is returning or anything else? How I am going to get? For example, it is going to be assigned with a variable name. For example, it is going to be assigned with a variable name. For example, result is equal to like this. Now look at the function call. If the function call is like this, the name of the function is sum. How many arguments I am passing? 2 arguments. What are the data types? Int and int. Is the function is returning anything? Anything? Yes, it is returning. Yes, it is returning. And what is the data type of that return value? What is the data type for res? That is int. That means the return type is not void. The return type is integer here. We have to analyze like this. When we are calling that function call, when we are viewing that function call, we have to observe all these 4 things every time. The first one is, what is the first one? First one is the name. First one is the name. We have to check what is the name of the function, how many arguments, and arguments data types, is the function is written, is the function has written? Yes, if it is a return, then what is the data type? Is the return type. What is the return type? We have to observe all these 4 things here. All the 4 things. Okay, name of the function, how many arguments I am passing, and what are the data types of each argument, and is the function is the return anything or not. We have to observe all these things. Okay, when we are going to observe all these things, then I am going to develop a function definition here. What is the return type here? The return type is integer. Okay, the return type is integer. What is the name of the function? Is sum. How many arguments I am passing? 2 arguments. Both are integer a comma integer b. We are going to develop like this. Okay, here it is int. That's why it is returning integer value. That's why I am writing here int is the return type. Sum is the name. How many arguments? 2 arguments, int sum comma int a comma int b. If the function is the return something, we have to write like this. Return, we are going to return every time some value, some integer value, right? For example, I am going to write like this. I am going to print the result. %d, comma res. There is nothing here. What I am returning here? I am returning 1 here. For example, if I am going to execute it, if I am giving 10 and 15, look at the output is 1 here. Why the output is 1? I am returning that function, from that function is 1 here. What I am returning here? 1. Then the 1 is going to be cached with this variable. Okay, the 1 is going to be replaced in res. What I am returning from the function, there is a cache here. The result is going to be cached that variable, and here I am going to print what is the result value? The result value is going to be 100. That one. Okay. For example, I am going to write here return now. What is the output here? Is it 100 or 1 or both? Anyone? Can anyone? What is the output here? Is it 100? Is it 1 or both? Students. Anyone? The output is always what is the first return value? Okay, what is the first return value? 100. Why it is 100? For example, I am giving 1 and 2 here, the result is 100. Why? Because if the result, if the return is executed in by our compiler, the control is automatically going back from that function to the main function. Going back to the main function, it is not staying here. If the return statement is found, then the control is automatically going back to the main function. It never stays in the function definition. Never stays in the function definition. That's why only one return statement will be executed. If this line is executed, it never executes that remaining one. It is automatically going back from the function if it is executed only. If it is executed, the below statements are never ever executed. It is automatically going back to the main function. That's why the output is 100 only. If you execute for 100 times, the output is 100 only. Okay. Now instead of 100, I am going to add here. I am going to write here a plus b. What I am writing here? What are the values I am passing? What are the values I am passing? I am going to give the result a plus b here. For example, if I am going to execute it, I am going to give some 10 and 15. The output is going to be 25 here. Okay, is it clear, everyone? Just note it down. Basic. This is the function definition. This is the function definition. Just note it down, everyone. What I am writing. When we look at the function call, we have to observe 4 things every time. What is that? What is the name of the function? And how many arguments are passing? What are the data types for each argument? And what is the return type of the function? These 4 arguments we have to observe every time. Okay, then only we can write, we can develop as similar to that functions concept. I think if you are writing the code in the CoCubes exam, for example, if you are, I think you are not written anything in CoCubes. I think if you go for the CoCubes exam, all the programs are based on functions concept only. Okay, how they are going to be developed here? The main function and everything. The result is also going to be already there. There is nothing to write in the main function here. That is already developed. The code, when you open that code, the main function is already developed. They given like this. Write your code here like this. We have to develop that function. We have to observe first of all. Yes, what is the name? Yes, the name, and yes, it is returning something. Then that means we are going to return some value and how many arguments, what are the data types, and we have to observe, we have to study the functional definition, and we have to write accordingly. Okay, like this every time. Put it down. This function is of type, the second one, right? With arguments, I am going to pass, these are the arguments, okay? These are the arguments. With arguments, I am going to return one value. Return one value, the second one, this is the most important one, okay?
Sir,
Hmm.
sir, in the upper part we are defining only the function,
Yes, yes.
and in the and remaining part the process will be the same.
Come again, come again. This is the functional definition, the development.
Yes.
Yes, yes.
And the remaining part, the process will be the same that we are means we are doing any program.
Now the same thing. What we have to develop in the function, we have to write the concept, the logic only. Okay, I will write this one. I will write this question in this format. Then you will understand more clear. Okay. Okay. Then I am going to write funds two. Funds two. These are the examples of functions. Okay, not the concept. I am going to yeah. This is the last example. Last example. What is that last example? Some test cases are there. In the test cases, I am going to search a digit, right? For the test cases and the test cases again, and I am going to read a number here, and I am going to read a digit. That's it. Okay. Now for the test case, I am going to write here, for example, percentage D. For the same thing I am writing here, T is equal to 0, T is less than equal to T, T is less than equal to T, T plus plus. Okay. This is the test cases loop. Okay. This is the test cases loop. I am going to read a number here. Read a number and a digit. Percentage D and percentage D ampersand number comma ampersand digit here. I am going to read a digit here. And instead of writing the logic, I am going to write here search digit function. Search underscore digit function, and I am going to pass a number comma digit here. I am going to pass here number comma digit. Okay, now I am going to pass. I am going to get some result is equal to. I am going to get some result is equal to. Just look at that. The result is always going to be. The result is going to be always only 0 or 1. That means is it true or false? It is written every time 1 or 0. Okay, 1 or 0. Just look at here. What is the name of the function? We are going to observe 4 things. Okay, every time. What is the name of the function? Search underscore digit is the name of the function. We are passing, how many values we are passing? I am passing 2 values, that is number and digit. Is the function is written anything? Yes, the function is returning something. And what is the data type for the result? What is the data for the result? That is going to be integer. We have to observe all these things. Okay, and the function is going to be like this, developing by the is equal to 1. It is going to be print as true here, else is going to be false. The program is already written like this. Okay, for example, the program is already written like this. Everything is done. Okay, everything is done here. If the result is 1, printf, it is going to be true, else it is going to be false. In some co-cubes and competitive exams, the questions will be like this. The question is totally right? Everything is done. Reading is done. Input is reading done, and output is also printing. Then what we have to do? The most necessary operation, the second operation. There are only three operations, right? Every time only 3 tasks. Reading input, displaying the output. The middle one. What is the middle one? Middle one is doing the operation. writing the logic is the operation, right? And that is going to be done in the search underscore digit functionality. This is the function call. This is the function call. Now I am going to develop that function call. What is the return type? The return type is integer. That's why I'm writing int. What is the name of the function? Search underscore digit. Search underscore digit. How many arguments I am passing? Two arguments. What are the data types? Int num comma int digit. And one more thing, here I am using the same argument names. There is no need to maintain the same argument names. We can write anything else. You can write anything else. Okay, not the same argument names, but the data type is same. Okay, the data type has to maintain same, not the names. Names are not mandatory here. Okay, the names are not same as mandatory. Here num I can take as num n. Here digit I am taken as a d. No problem here. If you take same also no problem. Okay, if you take same also no problem. For example, the questions will be like this. Write your code here. Everything is done. Everything is done. But we have to observe here from that function call. Yes, this is the function name and it. And if you observe from this, yes, this function is going to be return integer value. There are two integer values are there. That means here we also observe, yes, if returning 1, it is going to be print that true. For any other numbers, it is going to be false. Okay. Then we have to write, then we have to develop the logic based on this main program every time. Based on this main program, I have to develop here. That means look at here, the result is 1, it is going to be print true. If the result is 1, it is going to be print false. Okay, if the result is 1, it is going to be print false. Is my voice is audible, students?
Yes, sir.
like this here, we are going to develop the functionality. And what I have to do here, every time this is calling one functionality. Based on that main program, we have to write the logic based on this one. Okay, that means the result is going to be 1 for true and other numbers for false. Okay, now I am going to develop the same logic. What I write here, the same logic I am going to write here also. For example, here also. Okay, I am going to take int some r, f is equal to 0. Okay, take that like this. While there's no need to write f also, I will write here while num, while r is equal to num mod 10 and num is equal to num by 10. We are going to check if digit is equal to r here. If digit is equal to r, I am going to return 1 here. Here I am going to return 0 here. How simple I am writing here. Just look at everyone. I am writing return 1. If the digit is found, I am returning 1. That's it. Nothing else. There is a no. For example, there is a no printf statement. There is no f is equal to 1. There is no f is equal to 0 or there. I am directly returning 1 here. Why I am returning 1? Here, for example, if it is returning 1, the function definition, the control is directly going back to the main function, right? There is never stays. For example, there is no need to check here. We have to write in if condition here. Okay, why I am writing here return 1? If I am returning anything, the control is automatically going back to the main function. Okay, and here the return 0 I am writing. I am not written anything on the condition, right? Why not writing any on condition? Why? Because if this loop is going to be terminated, that means return 1 is not executed. That means the number is not found. If the control is coming out of the loop, that means the digit is not found in the number. That's why I am writing directly as a return 0. That's it, nothing else. Now I am going to execute it. If I am giving like this, okay, sorry. First of all, we have to give the test cases, right? The test case, 2 test cases, and the input is 1 and the digit is like this. This is going to be true, and the number is like this, and the digit is 8. The output is false like this. Why it is asking for the next time also? Okay, here I am taking as 0. That's why it is asking for the third time. No, we are not like written like this. We have to write for the test case 1 to test case is equal to right. That's why we have to write like this. Now I am going to display with every time as a /n. For example, these are the 2 test cases 1, 2, 3, 4 and 2. And 1, 2, 3, 4 and some 6, it is going to be a false like this. Is it clear everyone how I am writing using functions, the same concept using functions? Note down everyone the main functionality first of all. Write down the main, okay, don't write. First of all, write this functionality, the search digit function definition. I think, is it clear everyone? Is it clear? I will explain one more example with the functions. Okay, no problem. This is the function definition. Write your code here also you have to write. Okay, why? Because every time the questions will be like this. That's why you have to write like this. This is the function definition. Is it clear everyone why I am writing return 1 here? Return 1, and I'm not using any flag variables here. There is no need to check the flag variables. Directly if the result is found, yes, this is found, then immediately we are going out of the loop. That's it, nothing else. If the not loop, from the function only it is going to be going out of the function. Okay, if it is executed, the control is automatically going back to the main function. That's why I am writing without any conditions, without any flag variables. I am writing here return 1. And why I am not writing the return 0 in not any conditions? Why? Because if the loop is terminated without execution of return 1, that means the digit is not found in that number, right? That's why we are writing that return 0 outside the loop. That's it. Outside the loop I am writing here. Okay. Then note down the main functionality. The main functionality, everything is there. Just look at the inputs are read here, and outputs also printed here. The only one thing that is function call. That means we have to develop that function call. That's it, nothing else. Write this. This is a function call. Just you have to do one thing. What is that? Here I am telling that nearly some 10 to 15 programs, I think. All the previous programs try to convert all that 10 to 15 programs into the functions. At least 5 to 10 programs you have to write. Then only you will understand. Yes, this is the function call. Yes. Previously, I am going to discuss about nearly 10 programs. I think 10 to 15. I think. Just convert all the programs into the functions. Then only you will get a clear idea. Yes, we have to write like this. The function definition, then you will get a clear idea about all these things. Okay, every time we have to observe 4 things only: name of the function, what are the variables and the data types of the variables, and is it returning anything or not. If it is returning, what is the data type of that variable? That's it. Simple. One more thing I am going to develop here. The last previous program, that is lucky or not. I am going to convert this lucky or not as a new program. Okay. 3. Lucky or not. Okay. For that lucky number, we have to read only one number. I am going to write this program is also using test cases only. Okay. For t and small t, and I am going to read one number. That's it. And I am going to read here. Just observe everyone. First of all, the first one is for test cases. For the test cases, I am going to write a loop here. T is equal to 1, t less than equal to capital T, and t plus plus. This is for the test cases. And now I am going to read a number every time. Read a number every time. For every test case, I am going to read a number. Now, is it lucky or not? Is it lucky or not? For example, for the result also, I am going to return the result here. For the result is equal to lucky underscore num. Lucky underscore num of lucky just enough. Lucky of num. Here. The same thing if result is equal to result is equal to 1, printf lucky, else not lucky. Like this. Very simple, right? Just look at here. This is the function call. This is the function call. What is the name of the function? Anyone? Students? What is the name of the function? For example, I am going to write is lucky. Okay. Is lucky. Is lucky. What is the function name here? Is lucky is the function name. Okay. Students, is lucky is the function name. How many arguments I am passing? One argument I am passing here. Just look at one argument is passing. What is the data type? Int. Okay. And is the function is returning anything? Yes, it is returning the result value. What is the data type for the result? That is integer. Okay, simple things. Now moving into this function definition, how to develop. Int is the return type, and the function name is lucky, and we are passing one argument that is called integer. That is integer. Okay, that's it. This is the function definition. That's it. Very simple. Okay. For example, if you want to check is it working perfectly or not, just I am writing returns 1. If it is returning 1, the lucky is printed, right? For example, I am going to check it. For one test case, I am going to give one number. It is going to be written as lucky. Why it is returning lucky? I am written here as 1. For example, I am taken as 0. For example, I am going to take as test case is only one test case, not lucky. Okay, why it is not lucky? I am returning 0, that's why it is not lucky. We have to check is it working perfectly or not first of all, then only you have to develop the logic. Okay, that means here we have to develop either 1 or 0. That's it. I am checking is done. Now I am going to write the logic. What is the logic? If all the digits on the number are going to be divisible, then no problem, right? Then it is going to be lucky. All the digits, the number is going to be divisible by all the digits of the number, then only it will be divisible. Okay, no problem here. Now I am taking as some while here. While for that we have to maintain copyright every time. Int num1 num1 is equal to num here also is equal to num. I am going to write some while num1. I am going to take one more thing, that is going to be r here. Some r is equal to num1 mod 10. Then num1 is equal to num1 by 10. I am going to check that if num mod r is equal to 0, that means it is exactly divisible. If it is exactly divisible, if it is not exactly divisible, it is not exactly divisible, I am going to return 0 here. Okay, just look at here. If it is not exactly divisible, that means if the number is not exactly divisible by number, I am going to return 0 here. That means it is not a lucky here. For example, if it is crossing all the digits all the digits, that means it is going to be lucky here. For example, I am going to execute it. For example, that is a 2 for example, there are two test cases. There are two test cases. That is going to be 36. It is a lucky. And the next one is 248. It is also lucky here. In this way, for example, I am going to execute it. The two test cases, that is 98, not a lucky, and 234, it is also not lucky. In this way, we are going to develop the functions concept. Is it clear, everyone? Is it easy or not? Yes, it is very easy. Okay, note down the code. Note down the is lucky functionality. Is lucky functionality. Very simple. Why I am writing like this? Here, is it 0 or not? If it is 0, it is not lucky. It is 1 lucky. That's why I am writing this functionality. Now done. Within the main functionality. Main functionality is nothing here. If you observe, there is nothing in the main functionality. Reading the concept, that's it, and printing the result. But based on that main functionality, we are writing the logic. Yes, based on this one only, we are writing that logic. Here, the inputs are reading and output is printing. That's it. This is the main function. This is the logic here. We are going to develop in the functions concept. I think I will share in the GitHub, and I will share the GitHub link also. Today I will do it. Okay, no problem for that. Just listen carefully.